Thank you, Sasha. Thank you. I'm really glad to be here. This is my first time. I hope you are refreshed, and I hope I will do at least comparatively as my forerunners did. So my name is Petr. Petr in Czech. I am with Kiwi.com. I'm a senior software engineer, infrastructure, and I'm going to talk about how to secure workloads in the cloud and how to work with them with databases, because databases are not sexy, but they are important. So, can you hear me? Yeah. Why security? Well, because we are at Security Meetup, right? Obviously, we do care about security. I'm going to briefly go over why. How to do security in the cloud. I'm going to tell a little bit about that conceptually. Then, what we need to do to set it up in GCP. Why GCP? Well, it's one of the major cloud providers, and we use that. Who here is in the cloud? Who is having workloads in the cloud? Everyone, more or less? No one? No one is using the cloud? Really? Okay, who is using GCP? Some little bit less people. Who is using AWS? Azure? Okay, it's more or less the thirds. Right. Good. So, I'm not sure if I can be heard. I hope I can. Anyway, so I'm going to share some pitfalls later. We can do some Q&A. So the why. By the way, I'm going to present this in the why, how, what framework. I don't know if you know it. Simon Sinek had a great talk about this. Check it out. So what's the purpose of engineering, infrastructure engineering? First, our point, it must work. Firstly, before we are concerned with security, it must work. If our workloads don't work, no one cares about security, right? Our company doesn't work. We don't get money for affordable price. That's the second thing. If it's too expensive, again, no one cares about security. No one can pay for it. Monitoring and reliability, they go hand in hand, because you cannot really be reliable without monitoring, but they are equally important. So where does security fit in here? Everywhere and nowhere. Basically, security should help us. It should help us to provide clarity and to simplify things. If it doesn't, then it's just making our life worse and more difficult. And we are going to spend more time on it. And we're not going to be willing to do it because it's going to cost more money. So there is a shared responsibility model, not only as we usually know it, between the cloud providers like GCP, Azure, etc., and the company by itself, but also between the platform teams and the developer teams. The next thing about using cloud backend as much as possible, let me explain this to you with this note. So traditionally, and now I'm leaping into the passwords and accounts. Traditionally, people always used static passwords, static accounts. They have been saved somewhere in some files. More recently, in secret managers, they can rotate it. You can even have things like Vault, which are going to provide you credentials which are going to be rotated, etc. But this doesn't really solve the problem, right? The problem is that the static user account is just static. It's an example. You're going to connect to a database with static user account. From the perspective of a database, it can be anyone. You just see the endpoint. And if you want to know who connected, you need to know the IP address. So we're using cloud. Usually they have IAM, mostly. So we might as well use their backend as much as possible. And okay, Someone might argument, well, but we want to be portable. We don't want to buy in that much. I don't trust that. That's not a good argument. We are already bought into the cloud, and just by writing some Terraform code, it doesn't mean that you can just take it and the things that are deployed in GCP deploy in AWS. This just doesn't work. If you're in the cloud, you're bought in, and you might as well use the cloud backend to provide you these services, especially for this. Especially for security with the IAM identities. The identities, they are a thing. They are an entity in the cloud. So you can see them in monitoring, you can see them in logging, and suddenly it's not just someone connected to this database. It's this specific application connected to this database from here to there. You can see it in logging, you can see it in monitoring. You don't need to do full text search. So obviously, we are using GCP Cloud. So my examples are going to be based in GCP Cloud. There are similar concepts in AWS. There are similar concepts in Azure. So I'm going to also use Terraform because Terraform is the industry standard, I would say, and of Python. I'm sure you all know this, but the role of IAM in GCP is to connect things. Basically, there are different elements of the infrastructure which are communicating with each other. Compute is communicating with database, with storage, with PubSub. It's communicating through IAM. Again, this is the thing that I mentioned. So what's good about that? Well, IAM service accounts, unlike the passwords, they communicate with OAuth 2, with short-lived tokens, usually an hour. They're rotated, and we don't need to do anything about it. It's just provided, so we might just as well use it. And most likely, it's going to be better than in our company because Google has more manpower. So it provides cleaner auditing, cleaner logging, and also the IAM accounts can have attached roles and permissions, which we can control. And again, I'm going to be talking about databases because, well, talking about PubSub, that's quite easy. Why? Because PubSub or cloud storage, those things, they work with service accounts pretty well. There's nothing that difficult about that. But connecting databases, it's a bit different, but we can do IAM connections even with databases. So I'm going to do that as a case study. But firstly, how to work with IAM accounts in Kubernetes. Well, Kubernetes has its own role-based access control. It's a Kubernetes service account, and Kubernetes service account doesn't know anything about how Google backend works. So that's Google service account. How do we solve it? We bind the Google service account with the Kubernetes service account. Oh, we don't need to. Google did it. It's called Workload Identity. Basically, what they do is that they take the Kubernetes service account and they annotate it with the identity of the Google service account. There's some metadata server, etc. The workload identity needs to be enabled in the GCP cluster, GKE cluster, but mostly that's it. And this is simple. Then the Kubernetes service account, respectively the workload which we have, is going to communicate through the Kubernetes service account, but with the permissions of the Google IAM service account, and communicate with the Google Cloud API. That's what we want. That's one piece of the puzzle. Now we know how Kubernetes can work with service accounts. Good. So the second piece of the puzzle, how to work with IAM and databases. Well, this is a bit different. I can't tell you exactly how it works. I can tell you only what Google documentation provided, because obviously it's their internal tooling, their service they provide, and they have some good documentation on this. Basically, what happens is Google is running Cloud SQL instance. And in this instance, which is running the Postgres, is running also a proxy server. This proxy server, you can connect to this proxy server via a proxy client. And that application is Cloud SQL Auth Proxy. This proxy is going to connect on port, I think it's 3307, and create a secure tunnel to this database. It's a different connection than if you would connect to the database via TCP. That would be for Postgres standard 5432. So with this connection, which is by default encrypted via TLS and has short-lived ephemeral SSL certificates, you can connect to the database. How? Well, you have your application running here. On the same machine, you're going to start the Cloud SQL Auth Proxy. And the proxy is going to provide you the connection to the database. It's going to provide the encryption. It's going to provide the IAM authorization, because it's going to contact the Cloud SQL SQL admin API. And the Cloud SQL instance is going to verify that this user has permissions, roles to access this database. The communication between these two is not encrypted, which is why it's best if you can run them on a single machine. Well, one more thing, and this is these two things. Well, this is that it's just refreshed automatically. The proxy is going to create some token. It's going to refresh it on our basis. It can do automatic refresh for you, so you don't need to reconnect. Even in case of highly available instance, when you would have one of the instances drop down, if you have your code written well, and it's going to try to reconnect, it can use the same connection and reconnect again. Just the connection is going to be dropped for a brief time. But this thing is really good because previously, if you wanted to connect to the database, you could use the IP address, right? But everyone could. So you need to have it in VPN, which no one likes. This works without. So now I talk about a little bit about the conceptual point. One more conceptual thing, maybe if I can go back. The deployment modes of the Cloud SQL Auth Proxy. It can be either a proxy as a service, which is running on the same machine, or it can be a connector library, which you're going to use in your code. It's going to do the same thing. It's just a library. So if you're using one of these three, either Java, Python, and Go, you can, instead of running a separate service, you can just call it from your application. So now we are going to dive a little bit into how we're going to actually do it. So as I mentioned, Terraform is the industry standard. How to work with the workload identity. The first thing you want to do, use this module. It's written by Google, workload identity. What it's going to do, it's going to create for you not only the binding workload identity, but also both accounts, Kubernetes service account, Google service account. Why this thing first? Because obviously you're going to use it later. One note, don't forget to enable workload identity in your cluster. Otherwise, there's no metadata server. which is going to help you. So how to enable this in the instance called SQL IAM? Basically, you need to firstly enable this flag so that you can connect to the database. You can actually have a connection with you can assign the users to the database even without. If you're going to view it in the console, you're going to have a orange warning sign that these users are there, but they are not permitted to log in. This thing, it's not going to disrupt anything. It's just going to permit another action on the back end. That's very, very, very important, because unless you're starting on a green field, which most likely you're not, you're going to want to transfer. And you're going to transfer not in a big bang fashion, but as an evolution. And you're just going to enable this and then let the users gradually adopt it. They are going to need 2 roles. There are about 3 or 4 permissions hidden behind these roles, but these 2 roles, they are needed for the connectivity to the database instance. Well, not to forget, please focus on this thing. This is how the service account is going to be named. Before, I showed its name is my app. Project is my project. This is the Google standard. I don't know if you know it. Anyway, it's going to be service account, my app, at my project ID, at iam.gserviceaccount.com. Here, we are operating with the email. Here, we're creating the instance. Already when we are creating the instance, we're giving it the IAM user account, email, again, the email. We can put database flags, Cloud SQL IAM and authentication on. It's on by default, I think, but you can just provide it anyway. You will also need master user. That's a static user that's going to be in the database. And if you're going to want to deploy to a database with Terraform, it can only utilize the static master user. Or if you want to connect to it as an administrator and all other options are depleted, Cloud SQL Admin API doesn't work, for example, you can still connect on this port 5432. Eventually, if you need some static users, you can add them there. We don't like it, but what can we do? It's reality. And now I'm setting the roles. Role read write to my app at my project 1234556.im, not gserviceaccount.com. It's the IAM role in the database does not contain this suffix. It's just a mapping, but please be mindful of that. Otherwise, it's not going to work. So you can grant permissions to roles, and you can grant roles to IAM accounts. Now, who knows why did I do this and not Terraform? Anyone? Configuration database? No. Okay, I will reveal it in a bit. Yeah, that's closer. There is. So the answer is it's not going to be on the recording, so I'm going to repeat it. The first was that it's a different level, it's application and infrastructure, and this was that there is no module for it. There is a module for it. I didn't use it consciously. And I'm going to tell you why later. So what we have, we can connect to databases with IAM. We can use IAM with Kubernetes. Well, how to connect it? So the one thing, and the one thing only that you're going to find in Google Cloud Platform Docs is going to be use Cloud SQL Auth Proxy. And they are going to talk about how you can export JSON key files, etc., which just defeats the purpose in my mind. What you want to do is this. You want to connect from the application and enable IAM authentication. What this can do, this client library, which is by Google, it can do the authorization, and it can auto-negotiate the authorization for you. It can auto-sign in. It can rotate the SSL certificates, everything. You don't need to worry about this. So if you're using Python or Java or Go, I would just use this. Well, it needs application adjustments, right? You can use Cloud SQL Auth Proxy if you don't want that, if you don't want to touch your application. Valid point. So, pitfalls. And these are going to be things that we learned as we were going on this way. And one of the first is Postgres Terraform provider. So there is a provider for a very popular one for Postgres. And it has following issues. Firstly, it's going to create a provider block, or you are going to create a provider block, which is going to be bound to the instance. What this means? Well, provider blocks in Terraform, they are evaluated before any resource blocks. So if your instance doesn't exist, Terraform fails. So you need to do Terraform double apply and apply only with the provider when the instance is already alive, which is going to take, I don't know, 15 minutes, whatever. Same thing, you're destroying the instance, you forget to destroy the provider, well, then you need to go there manually, do some plumbing, and get rid of it. So that's one thing. The other thing, in the provider block, you're going to choose either Postgres or GCP Postgres schema. If you're going to choose Postgres, the Postgres schema, you're going to connect via IP address. Well, that's good, but IP address is not database connection name. Doesn't work with IAM. Not that good. Or you're going to use the GCP Postgres GCP schema. Well, that's better. You can do the connection name. You don't need to provide password. You don't need to provide the username. But if you're going to have 20 or 30 databases in a project, and you're going to have 5 users connecting to each, you're going to hit the API limit because the library under that sucks. So it boils down to this. Terraform is not a great tool for managing Postgres roles. It's Postgres roles. They are being set up in PLPG SQL. It's not a standard select statement, and it's procedural. Terraform, on the other hand, is declarative. So there is a bit of a problem in this. I think that's my theory, at least. Second pitfall, object ownership. And you will have, as I showed before, we are doing this, right? Grant role read write. This is just an example. Obviously, this is going to continue for longer for another object types, etc., statement types, etc. So why am I granting the role read write to this IAM account? Well, firstly, convenience. If I have more IAM accounts, I want to give them all the same role. So that's one thing. The other thing is, if I'm going to create a role which has permission to create objects, and I'm going to inherit this permission because that's convenient, right? When you sign into the database, you don't want to firstly do set role and then something. You want to just do something. Well, if you're going to do it, the objects that you're going to create are going to be owned by this. And that's a problem. Why? Well, imagine that your database is going to shut down. You don't need to know what's happening. You need to restore it somewhere else in a different project. Well, guess what? You're going to restore it in a different project. This user doesn't exist there. So you either need to add the user there or do some plumbing before. Not that simple. Maybe you even want to do something like restoring database periodically to enable your devs to work in sandbox with some sample of production data or something like this. And then it's going to be, again, major, not nice thing. So that's about the ownership and no inheriting and setting role. For role read only, obviously you can inherit everything, no problem in there. Reading, writing, and most importantly, creating objects, you want to be careful with that. If it slips, you want to fix it. But if you're going to create triggers on database, which are going to be fixing after every create statement, if you're going to have a workload that is going to create a lot of tables, you will see that your load on the database doubles because it's running this whole long trigger on every create statement. And this is another one interesting. You want to give administrative access to infra team, right? Because obviously the database owners, they need to take care of their databases. It's their thing, etc. But sometimes at night, your PagerDuty rings. You need to figure out something. You need to go to the database, take care for the production. You need to log in. Okay. So there are two ways how to do it. Either you can log in with the static account, which is there, that's the master user. But that means that you, again, need to go somewhere. Each database is going to have different password. You need to have it involved somewhere. Or you would say, okay, well, I have IAM. I just can put IAM account as administrator. Well, you can. But is every infrastructure engineer going to have this account in every database? Well, that would be complicated. So you want to have the hello? Okay. So I'm talking too long. You should have warned me. At least look more bored. Okay, so what are you going to do? You want to give access to the group, to the service account, which is going to connect to multiple databases. Because let's be honest, if you want to do some plumbing, fix something, you need an account with which you can connect to multiple places. But you don't want the security hole of having the same password everywhere. So this does the thing, but you cannot really add the group to the account. So you can add the group the permission to impersonate the account, and that's good. But then you will figure out that some of your databases are IAM enabled, some of them not. You need to figure out quickly which are and which aren't. So label the databases. That's a good thing. And perhaps provide some connection tooling, which is going to connect you to the databases via IAM account, if it's enabled, and via different account, if it's not. We do have some internal tooling for this, and I'm having some personal project in the making to help with this as well. So, my name is Petr, and I hope that you have some interesting questions.
Well, thank you so much, Petr. Do we have questions? Yeah, we have one question here.
Hello. Yeah, thanks for the presentation. I have a couple of questions. One is on this service account you mentioned. Is this available for all kind of services other than databases? I know this workload identity generally available, but so I was just confused seeing the service account as a proxy working for a client. When you say client, is it anybody can install the proxy and talk to the cloud public services?
Thanks for the question. So by client, I mean the client application, meaning that you have your developers, they have some of their applications, which is the client and client in the sense of client and server. So the database is the server, the client is the application connecting to the server. In that sense, that's what I meant. Regarding the availability of service accounts in different infrastructure element, let's say, not to overload the word service, depends. In Postgres, it works. In MySQL, it works. With databases in general, it's kind of more difficult. In AWS, they have similar concept. In Azure, they have similar concept. The accounts generally tend to work with Google Kubernetes Engine, with Cloud Functions, Cloud Run, some things like App Engine, etc. pops up, obviously with the cloud storage, but some things I'm not sure about so much. I'm not sure about, for example, the data proc, the things that emulate Hadoop or run Hadoop under the hood, etc. I'm not so sure about those. So it depends. You need to check if the service accounts work with your specific tooling as you wish, but if they are not at this time, the road is definitely that they will be at some point.
Thank you. Any other question? Okay, looks like everything is clear there.
Hopefully.
Thank you so much, Petr.
Oh, there's
a question. Sorry. Hiding.
Yeah, thank you very much. My question is a little bit generic, but why Postgres? I mean, of course, it is a rule of thumb is when you don't know which database you should use, then use Postgres. But still, in this exact case, why Postgres?
Well, why did I choose Postgres for this case study? Oh, because we are running 300 Postgres databases, and we did actually do a lot of tooling under the hood. We did our personal our company Terraform modules, which are working with this. So this is where I don't have just book knowledge in there. What I'm saying this is because we encountered these problems. This is because we learned the hard way. With different databases, I'm not sure that I could be providing this value.